Hello, in the previous video we talked about pH. In this video I will be talking to you about buffer. It may interest you to know how buffer keep the pH of a medium or solution constant. At the end of this video, you should be able to define a buffer compound. Give an example of a buffer, state the criteria for a buffer, describe how buffer works. Now let's start with the meaning of a buffer. A buffer is a compound that behaves in such a way as to resist changes in pH on dilution or addition of a moderate amount of acid or alkaline. A good example of a buffer is sodium bicarbonate, which is a good example of a buffer. Now let's state the criteria for a buffer. Number 1, it must be weak acid or weak basis solution. The point here is weak, so you cannot make a buffer with something like HCl because it is a strong acid. So it will have to be something like HNO2, which is nitric acid, because it is a weak acid. 2, you have to have that weak acid or weak base conjugate salts. Essentially, you have to have some kind of salt you put in solution that contain the conjugate of the weak acid or weak base. What is a conjugate? A conjugate is a compound that differ by one proton, e.g. NH3 and NH4, NH3 and Na4. So you can see that the formula is differ by one proton, that is one H plus, and because of that these two cannot be a conjugate pair. Now let's see. I said NH3 and what? NH4 plus. So the difference here is one proton. Now let's move to mechanism of a buffer system, and I said a good example is sodium bicarbonate. Now let's see the example here, how it works. Sodium bicarbonate, CO3. So it will give us sodium plus HCO3 minus. So when it dissociates, it will give us sodium and HCO3. Now this HCO3 is the bicarbonate. Now we said it reacts with the acid or the alkaline. So HCO3 minus plus H plus, what will give us? It will give us H2CO3. So you can see that the bicarbonate reacts with the acid to give carbonic acid. That is number 1. So the next one, let's make the reaction with an alkaline. So we have HCO3 minus plus hydroxy ion, which is OH minus, which will give us CO3 2 minus plus water. So HCO3 minus, which is the bicarbonate, plus OH minus it will give us carbonate ion plus H2O. Note that cells and tissues can only function properly at or around neutrality. They cannot tolerate fluctuation in pH of more than a unit or two. It is essential, therefore, that the pH of the body fluid should be kept as constant as possible. Any tendency for the acidity to increase is counteracted by the buffers which mop up the excess hydrogen ion, thereby helping to maintain constant concentrated ions in the cells. If the alkalinity is increased, it can react with the free hydroxide ion to form carbonate ion and water, as you've seen from the explanation before. Sodium bicarbonate can therefore resist a decrease or an increase in pH by mopping up the hydrogen or hydroxide ion as appropriate. In the human body, bicarbonates play a relatively minor role as buffer. Much more important are phosphate salts like potassium and sodium phosphate, both of which play an important part in suppressing the hydrogen ion concentration in the blood. The phosphates combine with the free hydrogen ion to form the dihydrogen biphosphates. Now, let me give you another example. Let's see whether the combination of this compound is a buffer. But before that, you should note one thing. One, is everything there weak? No strong substances. Two, do we have a conjugate pairing solution? So let's use it for this example. We have HCl and sodium chloride. HCl and sodium chloride. Now we want to know whether they have a conjugate pairing. Now the first one, I said no strong acid, but it must only be a what? A weak base. HCl, which is a strong acid, that means this cannot work, because you cannot pair a strong acid with a what? With a base. That means this strong acid cannot make a buffer with a what? With sodium chloride. Another good example is we have HF and AF. Now here, this HF is a what? Is a weak acid, which is a weak acid, and this KF will give us what? K plus and F minus. So definitely you can see that this F minus is a conjugate base of HF. So this F minus is a conjugate base of HF. So in this unit, you have learned that buffer are compound that keep the pH of a medium or solution constant on addition or dilution of moderate acid or alkaline. The pH of the body fluid should be kept as constant as possible. Any tendency for the acidity to increase is counteracted by the buffer, which mop up the excess hydrogen ion, thereby helping to maintain constant condition in the cells. Thank you for watching the video to the end. I hope it was fun and interesting. Ensure you read through the units from your courseware and answer the self-assessment question. You may watch the video again if you cannot get the total grasp of its content. Ensure you use the online charts on the LMS. I hope to see you in the next video. Thank you.